This video was sponsored by Flexispot. It's quite funny, recently I had this conversation with somebody and they told me that they didn't do DIY projects like the ones that we do here on the channel because they keep messing up. They feel discouraged from doing a DIY project. And it's not like I'm trying to purposefully edit that out of these videos, but oftentimes it just happens inside of your head, right? You make a cut and the cut didn't come out perfectly, you get a bunch of tear out or something like that. And you're just like, oh, that's horrible. And it happens like literally at every step of the way. Like usually it takes a little while to get around to the edit of these videos. And I remember at every step of the way I felt like I had failed, but it doesn't result in like the end result being worthless at all. Like all of those minor mistakes don't make a big mistake in the end. I feel like a lot of people don't get into DIY projects for that exact same reason. But if you just keep going, even though you've made a mistake, you'll eventually find that you actually finish it. And after a couple of years, you might find like, okay, I actually don't mind those mistakes as much. But essentially, like a little while ago, I got into resin printing. I really like resin printing, like the entire process of it is very relaxing and it's very fun to do. But the problem is I don't really have a dedicated space where I do these projects. Like this is just my living room and it's very recommended to do this in like a ventilated space essentially. That's not really possible in my print room. It has one window and that doesn't really circulate the air too well. There are definitely products that like connect to the back of your printer and filter out the harmful VOCs. To the best of my knowledge, these work quite well. The problem with those products is that it only filters out like the harmful VOCs. And so if I would like to verify if it's working properly by using an air quality monitor, I can't actually check because it still shoots up to like unsafe levels. Pretty much everything I build has to be somewhat on wheels, as I want it to be non-integrated, so I don't want it to be stuck inside of the apartment, right? If we ever get a different space or we move to a different location, we need to roll this thing out of here and then into a new spot and then have it work essentially straight away. The wheel size is pretty important for me as well because I wanted those to be at least like 9 centimeters off the ground because most robot vacuums are only 9 centimeters tall. And so once everything is bolted together, I grab the top section and I have the second jig which will allow us to mark out where we need to make a gap for the Flexispot legs. And I've 3D printed these pieces which fit inside of that gap and allow the Flexispot legs to sit inside of that as well. And then I put those wooden boxes at the side in place. These are a little bit smaller because I cut them down with a circular saw before so that the side panels would actually be able to connect to it. As for the side panels, you can kind of see here that initially I wanted windows on both sides, or actually in the first place I wanted this to be completely out of plexiglass, like everything, also the sides. But I didn't think it would work because you couldn't get that airtight. Wanted it to somewhat look like a really old-fashioned diving bell or something like that, like a submarine thing with like a bunch of bolts holding the thing in place. And then I drilled those out with a normal drill. I attempted to do like a full through cut, but it kept setting off the fire detection system on the laser cutter, so I wasn't able to do it in that way. I had to go past it with a jigsaw. Yeah, it's taking form. Like it's a box, it has a bunch of holes in there and it goes up and down. Now the legs that we're actually using for this project are the E5s from Flexispot. I bought them myself, but Flexispot is also sponsoring today's video. They also offer a lot of like other ergonomic accessories. In this use case, we're using the legs for a very different thing than what they're intended for, but you can use them in a more standard scenario as well. Like I have the E7s under my workbench, and I actually recently had a scenario where I needed to do some work on the ceiling. I couldn't find my ladder, and I used the workbench to lift myself up to the ceiling, which was actually really quite useful because you have quite a lot of room on the workbench itself to put like a bunch of bits and drills and that kind of stuff on there. If you go for the E7 Pro model, it's even higher at £440, which is quite a lot of weight. You could have like a full setup on there and then sit on top of it as well yourself and lift the whole thing up. So I've done this once before on the channel, but I think a really great method of showing you how well they're built and actually making this integration useful for you is like taking these legs apart. So you can take off the 4 bolts for the casing that like protects it, and that just comes off really easy. Then you're greeted by the electric motor, and that electric motor is held in place with 2 bolts. When you unscrew those, that entire section kind of comes off, and I really like this because it's very easily user replaceable, right? So it comes with a 15-year warranty, and yeah, you can really see why that is. Like they constructed these things really solidly, and if anything ever breaks, it's a really easy fix essentially. And when you take off the next 2 bolts, you can actually unscrew that entire segment over there, and you can see like a massive thread that goes into a separate column section which is inside of the legs. And so when that electric motor turns that thread, then it adjusts the height. But it's really nice to see how well these things are constructed in terms of like the automotive grade steel that they use, which is like 3mm thick. That's very different from the other like sit stand legs I've tried over the years, which are really like flimsy and like made of aluminium. So the control panel is also really decently constructed, and you can press the M button to select like one of the presets, and it will go back down to the height that you have it currently set at, which is pretty essential for this setup because we don't want it to go too low. And yeah, it has a feature in there as well which prevents it from crushing stuff. So when there's something underneath the desk setup, then you know, it hits it and then it goes immediately back up. So there's currently a Christmas sale going on, and you can save 65% off your order. I also left a discount code in the description down below. If you use that code, you can save an additional $50 off your order. So special thanks to Flexispot for sponsoring today's video. So at this point, you know, I'm really freaking out because I had spent a lot of money on wood and my time trying to build this thing, and it looks really bad at this moment in time. I wanted it to look way better, and that's the thing with like 3D modeling stuff in CAD. In CAD, everything is straight, everything. It seems like you're going to be able to build this thing in a single day, and then when you actually start building, it doesn't end up being like that. So I made an effort to, you know, tilt it up onto its side and go past it with a circular saw, just to chamfer the edges and get everything kind of aligned with each other, so that in the hopes that it will look a little bit more uniform and not look too out of place when it's eventually all put together. I thought I'd put the extraction hoses at the top of the setup. For some reason I decided against this because I thought it would be very useful to have some space at the top of this thing to put extra items. So I went back to the laser cutter. I got some 5mm thick multiplex, and I cut out those round gaps again, but this time as like face plates for it, and also a 100mm hole in the middle, which will 3D print like a little cap for that we can attach the extraction hose to. I then also took like a really simple PC case fan to the 3D scanner. And we don't really need to 3D scan it, but I've made it a point to 3D scan pretty much everything, so that I have a lot of the stuff that I use for projects in this iPad. And you know, if I ever find myself on a location where I don't have access to the 3D scanner or anything, and I have an idea for a project, then I can model it out with the 3D scans I have available. So I also took the opportunity to 3D scan some power strips, which are like really cheap power strips here from the Action in the Netherlands. Basically imported that into Shaper 3D and made a wooden casing for it out of 5mm plywood, which we can then cut out on the laser cutter. You can make like a 3D printed mount for this as well, but I've noticed that 3D printing stuff takes quite a lot longer than just putting a sheet of multiplex in the machine and having that finished in like 5 minutes. So that's why I do it this way. So I bought some of these 3-prong power connectors, which you usually see in power supplies for computers. I designed it in a way that you can just use a standard hole saw and really quickly make a gap inside of one of these setups. Input this 3-prong power plug thing, and then it's ready to go essentially. After that I also 3D scanned the control panel of the Flexispot legs so that we can mount that on the outside of this casing. I do this quite a lot on the channel. Pretty simple, you know, I just need the angle between where the control surface is and where the mounting points are. I 3D printed those components on the Creality K1C. I bought that machine myself, and I've never had too much success with that printer, and I don't know why it is. Like, I've used a different slicer once before, and then it turns out way better. But when you use the Creality slicer, I'm probably inputting one of the settings incorrectly or something, but the 3D prints come out looking quite horrible. So if you're enjoying the video so far, then definitely consider subscribing. If you don't subscribe, then you might miss a future build video because it doesn't end up in your suggested feed. And yeah, you might never see another one of my videos in that way. Now the power strip actually needs to be on the inside of this setup, and I should have like considered this beforehand and like jigsawed out a piece beforehand, because you know, the vertical lines were fine, but the horizontal lines I couldn't get the jigsaw in there, so I used a hole saw in this case again and cut out those gaps for it. But that is kind of a issue I see for this whole situation, is because the Flexispot legs are inside of this device. If something fails, or like the power fails, or the power strip fails, we won't be able to get that top compartment off. So I actually haven't screwed that top compartment into the Flexispot legs yet, and I don't think I'm going to do that, because if it ever locks up into that position and I need to get to the 3D printer, that's going to be an issue. So I'd rather have it be able to lift it off the Flexispot legs to get to the 3D printers. So after that I attached the PC case fan, and I'm not entirely sure if the PC case fan is strong enough to actually circulate air around in this thing, but I'm hoping that the VSCs will just choose like the easiest path to get out. Like, it's almost like I'm anthropomorphizing the VSCs here, but if that's not the case, we'll have to get some of those larger fans which actually are made for these tubes. But those are quite expensive, so I'm hoping this works. So I also ordered some of these rubber seals which you put in between doors if you have like a draft, and I put that at the bottom compartment so that when that whole contraption lands on it, then it seals it off. Now that I'm thinking about it, it might have been better to actually attach it to the top compartment. So I kind of wanted to see where this thing would be leaking, because we kind of have to take it apart and put it inside with the 3D print room still, and that's why I haven't kitted anything up yet. But I was expecting to have to kit up pretty much everything, like the windows and that kind of stuff. And I have a smoke machine, so I put the smoke machine in there, ran the control panel outside of one of the tubes so that it wouldn't cause a gap of itself. And yeah, pumped it full of smoke. I saw that there was some leaks at the top of the compartment where it would meet the top section. I'm not entirely sure if that's a valid method of testing, because VSCs might interact with the environment differently. Like, they might be heavier or something and fall to the ground, whereas smoke kind of floats all over the place. I do have an air quality monitor that I can use to test for VSCs, and I'm only going to do that once it's in the 3D print room. That will be a separate video, and yeah, I hope you stick around for that. We can see if this thing actually works or not. I hope you enjoyed.